A very hearty welcome to the students in my channel of Open Mind. So students, we have gone through many chapters of mathematics and a chapter of physics which is known as light. Now we will be discussing another chapter of physics which is called as electricity. So light and electricity are two main important chapters of physics, and these two chapters contains many numericals also. So we will discuss the numericals later on. First, let's see the theoretical part of electricity. Now, electricity, whenever the word electricity comes in our mind, the first word comes is charge. So we know what is a charge. A charge is, what is a charge? So charge is an ion. You might have known in case of your chemistry, whenever we consider that a charge is an ion, if it is a cation or an anion. If it is a cation, it is positive charge. If it is an ion, it is a negative charge. So here when we talk about electricity, first we say what is a charge. So the charge is an ion. That means, example, you can take it as like a sodium ion and a chloride ion, etc. But in case of physics, we indicate the charge as Q minus and Q plus. And what is the unit of charge? The unit of charge is coulomb. Unit of charge is coulomb. Okay. Now we can say that what is electricity. Now we will see that how the electricity flows in a conductor. So now I am making a conductor. Suppose this is the conductor and I am connecting this to the two ends of a cell. So this is the positive end of a cell and this is the negative end of a cell, and this is one end of the conductor and this is another end of the conductor. Now whenever these two conductors, whenever the two ends of the conductor are attached to a cell or a battery, so what happens, the potential difference between the two ends of the conductor increases. Whenever the potential difference increases, the charges, these are the negative charges, it will start moving towards the positive charges in this way. So as a result, the charges are flowing in this direction. That means the charges are flowing from negative to positive direction. So the current will be flowing from positive to negative direction, because it is always opposite to the flow of the charges. The flow of charges is always from negative to positive in case of conductors, whereas the flow of current will be always from positive to negative. Now there will be a question in your mind that what is current? So it is represented by I. I will be equals to Q by T. So you can say that rate of flow of charge is called as current. So rate of flow of charge is called as current. Okay, so this is I. The current is represented by I. Rate of flow of charge means in 1 second how many charges are flowing from one end of the conductor to the another end of the conductor. That will be equals to Q by T. Now there are two types of current. The first one is directional current and another one is convectional current. So what is directional current and what is convectional current? So the directional current is that which flows along with the direction of the charges. That means the directional current always flows from negative to positive. Since the directional current is very less, it is almost negligible. So we cannot consider it because it is a negligible quantity. The amount of current flowing is very less, which is flowing along in the direction of charges, whereas whatever we consider, that is called as convectional current. The convectional current is that amount of current which flows from positive end of the conductor to the negative end of the conductor, and it measures if the rate of flow of charges increases, there will be always an increase in the convectional current. If the rate of flow of charges decreases, then there will be decrease in the convectional current. So how can you increase the rate of the flow of charges? The rate of the flow of charges can be increased by increasing the potential difference between the two ends of the conductor. This is attached to the positive end, this is attached to the negative end. Here we are using one cell. If you want that your current should increase, so you have to increase the number of cells. So that is called as battery. So what is a battery? A combination of cells. So combination of cells is called as battery. Okay. So now suppose this is one cell. If we want to increase the amount of flow of current, we will make this type of symbol. So this is the symbol of battery, and this was a single, that is plus and minus. This was the indication, that is this is the symbol for a cell. Now we will see that I is equals to Q by T. Now what is the unit of current? The unit of current is called as ampere. So it is called as 1 ampere. So 1 ampere is equals to 1 coulomb by 1 second. So if someone asks you the question that define 1 ampere, so what is 1 ampere? So when 1 coulomb of charge flows through the conductor in 1 second, then the amount of current flowing through the conductor is said to be 1 ampere. Okay, so I'll just write down the definition so that the small definitions will help you out to solve your questions very clearly and to clear the concept of the electricity. Okay, so if someone says you define 1 ampere, suppose there is a question comes, define 1 ampere. Okay, so this is the question. So what will be the answer to this question? The answer will be when 1 coulomb of charge flows through the conductor, in 1 second, then the current flowing through the conductor is said to be 1 ampere. Okay, so I think now this concept is clear to you. What is current? Rate of flow of charges is called as current. Always the charges are measured with the help of a unit which is called as coulomb, and time is measured in seconds, and the current is measured in amperes. So what is 1 ampere? When 1 coulomb of charge flows through the conductor in 1 second, then the current flowing through the conductor is said to be 1 ampere. And also we saw there are two types of current. One is directional current, which is flowing along with the direction of electrons, and another one is the convectional current, which we considered. Directional current is very less, so it's negligible, and convectional current is the amount of current which we use or which we calculate. So that current always flows from positive end of the conductor to the negative end of the conductor. Now see, here we will see another topic which is called as potential. There is one more unit of charge which is called as Faraday. So Faraday was a scientist, and he was the one to find out two laws. Those were known as laws of electrolysis, and through that laws he found a relationship. That relationship is, if you say, suppose you are using the very large amount of charges, so in order to, then we cannot say every time coulomb. In that case we can use Faraday. That is 1 Faraday, there is one relationship, that is 96500 coulombs. So if it is 96500 coulombs, no need to use coulomb, you can use your unit as Faraday. Now we will be seeing what is potential. Just keep it in your mind. I am putting this in blocks so that you can remember it and you can use it while you do the numerical questions, not only in 10th class, in your next classes also. Now what is potential? Now as I said you that whenever the charges flows from one end of the conductor to the another end of the conductor, there is some work done. So that is indicated with the help of potential. So mathematically it is represented by V is equals to W by Q. So now what is this V, what is this W, and what is this Q? V is the volt, that means it is the potential, W is the work done, and Q is the charge. So you can write it down. Suppose there is a charge over here Q plus. Now the amount of work done in bringing a unit positive charge from infinity to that point. Suppose you want to bring the charge which is lying at infinity over here to this point. So the amount of work done in bringing a unit positive charge from infinity to that point is called as potential. There is no kinetic energy which we use in this condition. So you can express it in your words as the amount of work done in bringing a unit positive charge from infinity to that point is called as potential. So I hope you people understood what is potential. Now with this, you know that there are three types of substances, or you can say there are three types of elements. The one is the conductor, the second one is the semiconductors, and the third one are the insulators. Now do you know the differences between these three? You know, you always say that conductors are those substances or are those metals which allows the electricity to pass through them, whereas the semiconductors are those which allows partially the electricity to flow through them. For example, germanium and silicon, they are the best examples of semiconductors. And third one is insulators. Insulators are those substances, or they are those elements which do not allow electricity to pass through them. For example, wood, plastic, etc. So these are the certain examples. So conductors also, you can say, give any example like iron, copper. They are very good conductors, copper and iron. The best conductor of electricity is copper, because copper is widely used in making wires. Since copper is very expensive now, you can replace it with the help of aluminium wires. But remember, if you are connecting to ACs or refrigerator, try to use the copper wires. Don't try to use aluminium wires, as its resistivity differences are there for both copper and aluminium. So now let's come to our original discussion. So we were discussing about what is the potential. So I said you the amount of work done in bringing a unit positive charge from infinity to that point is called as potential. Now second come potential difference. So what is potential difference? Potential difference is, here we bring a unit positive charge from infinity to that point. Here we take a conductor. Suppose this is a conductor, and the amount of work done in bringing a unit positive charge from one end point of the conductor to the another end point of the conductor. So that is called as potential difference. The potential difference is whenever you are bringing a unit positive charge from one end point of the conductor to the another end point of the conductor. So that is called as potential difference. So I hope you can write it down in your own words, or else I'll just help you out to write it down. The amount of work done in bringing a unit positive charge from one end point of the conductor to the other. So in this way, in today's class we learned three things. The first is what is charge. The second is, so anything, like suppose you take any element, suppose we take an element sodium. So whenever it's lose its electrons, it becomes sodium ion. That means it gains which kind of charges? A positive charge. Similarly, you can take the example of chlorine. The chlorine has 17 electrons, so its valency is 7. When it gains 1 electrons, it becomes chloride ion. So in that cases, it becomes an anion because it is negatively charged. So then we found out, so in this way, those are the charges. Charge means anything which has some capacity in itself. Then the second one is what is current. So rate of flow of charges is known as current. You can represent it as mathematically I is equals to Q by T. Then what is 1 ampere? That also I defined that when 1 coulomb of charge flows through the conductor in 1 second, then the amount of current flowing through the conductor is said to be 1 ampere. After that, two topics. One is what is potential. So the amount of work done in bringing a unit positive charge from infinity to that point is called as potential, and the amount of work done in bringing a unit positive charge from one end point of the conductor to the other is called as potential difference. So in our next classes we will discuss the other topics of electricity. Please continue, and if you have further doubts up to here, let me know. It will be a great pleasure to solve your doubts. Till then, bye.
For more updates, subscribe our channel, click the shown links and enjoy watching the videos.